All right, here we are, part two of emission systems. We left off with PCV systems and this fresh air breather tube. So moving on from here, let's take a look. We have secondary air injection. So the first air injection systems added air to the exhaust manifold to complete combustion of hydrocarbons. Basically, you're adding air. Here's your system right here, little diverter valve. You're going to add air down here in the exhaust manifold, and that heat in the exhaust with the air is going to burn some of those raw hydrocarbons or raw fuels. Now we kind of run them down here into the catalytic converters to help promote combustion of exhaust gases in the converter. Helps them run a little more efficient, increases that temperature to burn off that raw fuel. So three different types. We have belt-driven pump, pulse air, and electric pump for secondary air. But basically we're taking atmospheric air and it's going to be injected into the exhaust system. And again, there's diverter valves that help for the exhaust. So the exhaust is push up out of that system. Turbo canister, talked a little bit about this on fuel systems, but basically stores fuel vapor, those hydrocarbons. So what happens is fuel evaporates out of the tank. It's going to go into the charcoal canister and kind of absorb into those charcoal little pellets. And then when the system gets turned on or wants to be purged, you're going to, it depends on the system. OBD1, you just turn on the purge valve. These were open to atmosphere. OBD2 vehicles, newer sealed system ones would have. You're going to have a purge valve up front and a vent valve in the back. So the computer would turn on these solenoids or turn off or turn on, depending on what mode they were in. But the premise is what's going to happen is as the engine sucks or the vacuum pulls the vapors out of the canister, it's going to pull in fresh air from the atmosphere and it's going to push and purge all those fuel vapors that are going to go purge tube to solenoid, and that's going to go up to the engine to be reburned and be part of that air fuel mixture. These systems are fantastic. They eliminate all those vapors coming off gas tanks that I remember as a kid. You know, you'd see them kind of the squiggly lines and the distorted image above gas tank filler necks. You don't see that anymore. So these systems have helped a lot of hydrocarbons be removed from the atmosphere around us. Again, if you're going to fill up your gas tank too, kind of an old tech tip, if you know when it clicks and turns off, don't keep clicking it because you can get some raw fuel into the charcoal canister and you don't want it to get ruined. It's not meant to have liquid fuel, just vapors. So again, when it clicks off of the pump, you're good. You know, one click and you're done. EGRs, exhaust gas recirculation valve, talked a little bit about these. Basically, they're going to run inert exhaust gases into the intake manifold, lowering that displacement, lowering pressures and temperatures, lowering NOx. So you have a diaphragm style here, and this little vacuum is driven off of engine vacuum, and it pulls this plunger out and redirects air from the exhaust to the intake. But it has this little guy right here, will go to something very similar to this on the left, this little vacuum switch right here. This is being controlled by the computer to turn on vacuum to the EGR so it can move this plunger. And then the computer can tell the system's on with this guy right here. It's unplugged, but this DPFE, differential pressure feedback EGR, this system right here is going to have these two tubes that go across an orifice, and it's going to be able to tell whether or not EGR is flowing or not. Up here we have an electronic EGR with these three different solenoids. They have different sizes, so any combination of operating these can achieve the correct flow. Those are highly used on GM vehicles right here. And then we have the catalytic converter. Contains platinum, palladium, and rhodium, precious metals. These are just little science powerhouses, little chemistry labs running around, catalyzing all the nasty, obnoxious gases into sunshine and daisies. That's what it does. They're right here. So, nope, there's going to be a video again to watch that's pretty cool. Explain how these little science labs work. And in here, this is a picture of something in their early 80s, late 70s or so, talking about add-on parts, emissions. Here you have your diverter valves and your smog pumps and thermactic air cleaners, all these vacuum lines and solenoids and EGR and vacuum switches, and oh man, it's pretty bad in the 70s. They're domestic vehicles, but it didn't get much worse. I mean, imports had the same problem. Here we're looking at some here you got some vacuum switching right here going on. So we got an old Toyota. You got vacuum switching going on here to EGR. Look at all these lines and purges and vacuums, thermactor and cleaners and heaters and oh man, ton of stuff. All that stuff has to be operable and working. So smog tech in the 80s and 90s, they really had their work cut out for them. A lot cleaner now. So here's some more import stuff. So it's open air cleaner. Yeah, it's not smog legal, depending on where you're at. But yeah, take a look at all this stuff here. A little cleaner though. This looks like more 90s vehicle. And then here's a diagram of a vacuum valve or vacuum diagram, like vacuum hoses there. But basically here's your carburetor base, and then here's all the PCV systems and all these. This is the hose diagram. Here's charcoal canister and purge valves and temp sensors and thermactic cleaners and fuel evaporative heating grids and all kinds of stuff here that you had to make sure the systems work. I remember having to put some 1970s vehicles, particularly this Dodge motorhome, that engine caught on fire. I had to re-hose one of these to be smog legal, and it took quite a bit of work. And that was pre-internet, so you couldn't just Google what it looked like. I had to look at this diagram or go to the junkyard. I'd go to the pick and pull, look what a normal 1978 Dodge looked like, and then kind of write it down, write my own notes, and then come back and put it together. So, and then here's one. Looks like a Honda 80s. Ton of vacuum lines, just crazy amount of lines. You used to have to mark these with whiteout, but we don't see that much anymore. Looks a lot newer now. So anyway, that basically wraps up emissions. There's going to be a video attached for how the catalytic converter works. There is a whole lot more to emissions. This is by far and no means all inclusive. There's a whole class that you spend 17 weeks on just talking about emission components, how to test them, again, their theory, operation, diagnosis, and their purpose. So yeah, hopefully it's been a little bit insightful. We talked about some of the main ones, along with the fuel video that we talked about last week that gives you an idea of so many control components that have to be working perfect for these systems to work balanced and emission free. Any one of these don't work, and that's where you get a check engine light, or systems get inoperative, don't operate as desired, and then we as technicians get called upon to fix them and make it right. So hopefully this has been helpful. If you have any questions, email me, and I will see you later.